Hello and welcome to Auten Math. In this edition of Auten Math, we're going to take on some problems that require us to understand the unit circle and reference angles in our attempt to find the trig functions of any angle. So the first question asks us to find sine, cosine, and tangent of an angle with a given point 8, 15 to the nearest tenth. So what we're going to do is we're just going to find the fractions that are involved in the different trig functions. So the first thing I want to do is I want to mark out my point here. So I'm going to measure this as 8 units along the x-axis, and we'll say this is 15 along the y-axis. So my point is 8, 15. So then I'm going to draw my right triangle based on that point. And then I'm going to evaluate based on the relationships that are required for the trig functions. So the first thing I'm going to do is I'm going to find sine. Sine is the relationship of the opposite to the hypotenuse. And by the way, if you remember your Pythagorean triples, you'll realize that this is an 8, 15, 17 triangle, or you can use the Pythagorean theorem to figure out that the hypotenuse is going to be 17. So sine of now this angle is going to be 15, or the opposite side, over 17. Then cosine is going to be the adjacent side, which is going to be 8 over the hypotenuse, which is 17. And then tangent is going to be the opposite side, or 15, over the adjacent side, or 8. So there are your relationships, or your values, based on the sine, cosine, and tangent of a measure whose side lengths are 15, 8, and the hypotenuse of 17. In the next question, we're asked to find, again, sine, cosine, and tangent. And we're not going to find the sum. We're just going to find sine, cosine, and tangent of an angle with a radian measure of 7 pi halves. So we have to remember, again, our formula for converting radians to degrees, so we can evaluate the angle. And pretty soon you'll be able to just take a look at a value in radians and figure out what that value represents in terms of degrees. So for every pi radians, we have 180 degrees, and here we have 3.5 pi radians. So that means I'm going to move my angle 180 degrees, that's 1, another 180 degrees, that's 2, another 180 degrees, that's 3, and then another 90 degrees, that's 3.5. So this is the equivalent of 270 degrees, although this angle itself is going to be 630 degrees. So we've got 360 again, and then another 270. So it should be 630 degrees. So 270 degrees, we're going to find the sine of that value. So the sine, if we think about our unit circle, we see that at that point, our value for x is 0 and our value for y is going to be -1. So the sine is going to be just the y value, or -1, over the r value, which is 1. So my sine value is -1. Cosine is going to equal the x value, or 0, over 1, which is equal to 0. And the tangent is going to be the y value, which is -1, over 0. Now this means that this value is going to be undefined because we have a 0 in the denominator. Next step is to find the reference angle for the following angle. And so in this case our angle is 100 degrees, so we'll mark that out on our xy coordinate plane. Here I have 90, and then I have another 10 degrees. But remember, the reference angle is the acute angle that's made between the horizontal axis and the terminal side. So here's my acute angle. I've already taken up 10 degrees here, so I know that this reference angle is going to be positive 80 degrees. So a reference angle is always going to be initially a positive value. And as you recall from our lesson for this particular chapter, the reference angle will change the sign to find the actual value based on its placement in the different quadrants. Okay, so we're going to find the reference angle 80 degrees. Now let's take this a step further. if we want to find the sine of negative 100 degrees, first thing we do is we find the reference angle. It's 80 degrees. We find the sine of 80 degrees. So in this case, we're going to have to use our calculator. So we say the sine of 80 degrees. That's equal to 0.985. And then we identify the quadrant that this value is, the value of the angle is in. It's in the third quadrant, so we know that y is negative in this quadrant. We know that sine also must be negative, so we change the sine of the value to negative, and we have negative 0.985 degrees for a reference angle, for an angle of negative 100. In the next question, we're asked to find the tangent of 240 degrees without using a calculator. Okay, so again, we have 240 degrees. We want to find the reference angle for 240. So we're going to map this out on our XY coordinate plane. I have first 180, and then I have another 60. Okay, so the reference angle is the angle made with the terminal side and the x-axis. So here's my reference angle. It's going to equal 60 degrees. Now I want to find the tangent of 60 degrees. So I lay out my right triangle. Here is 60 degrees. Here is 30. I know that this is root 3 if this side opposite the 30 degree angle is 1 and the hypotenuse is 2. So my tangent is going to be the opposite side, or root 3, over the adjacent side, which is 1. So I can say that it's going to be root 3 over 1, or just root 3. Now I have to figure out what the sine, S-I-G-N, is of tangent of 240 degrees. And I do that by considering what the y and x value, the sine of the y and x value are. The sine of the y value is negative in the third quadrant. The sine of the y value is negative in the x quadrant. So that means the value of the tangent in the third quadrant is going to be positive. So my answer is going to be the square root of 3.